Have you ever written a piece of code that, it works, but it just feels kind of dumb? Well, today we're going to fix that. We are taking a super simple guess the number game and giving it a serious intelligence boost. We'll teach it how to give smart hints and, maybe more importantly, how to let you keep playing until you actually win. Ready to see how it's done? Let's get into it.
And really, this is the core question, isn't it? I mean, a computer can tell you you're wrong all day long. That's easy. But how do you get it to tell you why you're wrong? To actually guide you toward the right answer? That right there, that's the difference between a program that's just frustrating and one that's genuinely helpful.
So if you remember the last version of our program, the logic was about as simple as it gets. You'd make a guess, and the computer would use a basic if and else statement. It was a totally binary world. You are either 100% right or 100% wrong. No in between.
And that right there is our first big problem. Just think about it. You're playing the game, you guess, say 50. The computer just says, not correct. So, what do you do next? Guess 1? Guess 100? You have no idea. That one unhelpful response makes the game feel like a total shot in the dark. We can do so much better than that.
Okay, so this brings us to our first major upgrade. We are going to give this program the ability to provide really specific, meaningful feedback. It's time to move out of that simple correct or incorrect world and into one where our program actually gives us useful information.
And here's the magic trick. On the left, you see our old kind of blunt else block. But on the right, that's the upgrade. Now look closely at what's happening. All we've done is put another if-else check right inside the original else block. This one simple move is the absolute key to creating programs that are way more nuanced and intelligent.
Now, to make these new comparisons, we use these little tools called relational operators. You've actually already used one, the equal sign, to check if the answer was correct. Now we're just adding greater than and less than to our arsenal. They look simple, but these symbols are basically the foundation for all decision-making in your code.
And this technique we're using, well, it has a name. It's called nested selection. Now, it might sound complicated, but it's exactly what you see on the screen. We're just nesting a new if-else statement inside our original one. This lets the program check a second condition if the first one fails, which is how we get these multiple specific outcomes.
So let's trace the computer's thought process here. You guess 50. The computer's first question is 50 equal to our target, 42? Nope. So it immediately jumps down to the else block. But now, because of our nested selection, it asks a new question. Okay, is 50 greater than 42? Yes, it is, and that is exactly why it prints too high. It's a perfect illustration of the logic in action.
So here's the really crucial point. With just a couple of extra lines of code, we've completely changed the game. It's not a random guessing game anymore. It's now a game of logic, where every single piece of feedback from the computer helps the player zero in on the correct answer.
Okay, we've solved the feedback problem, but in doing so, we've kind of created a new one. The game is way more helpful for sure, but it's also over in a flash. You make one guess and the program just ends. So how do we fix that? How do we give the player a chance to actually use that awesome new feedback and guess again?
So how do we let the player keep guessing? Well, the answer is repetition. We need to teach our program how to loop, how to repeat the game's logic over and over until the player finally wins. Let's dig in. The tool for this job is something called iteration, and specifically, we're going to use the while loop. You can think of a while loop like a persistent gatekeeper. It checks a condition, and as long as that condition is true, it just keeps running the block of code inside it again and again and again.
And this is what our new code looks like. See how that while loop basically acts like a wrapper or a container? All of our smart feedback logic, the too high and too low stuff, is now tucked right inside it. This simple structure is what gives our game its replayability.
Now, the real engine of this loop is its condition. That little not equal to symbol just means not equal to. So what we're saying is, as long as the statement guess is not equal to target is true, keep this loop running. The very second the player guesses correctly, that condition becomes false, and boom, the loop stops. That's how the program knows the game is over.
But of course, with the great power of loops comes a great risk. I'm talking about the dreaded infinite loop. This is, without a doubt, the most common trap you can fall into when you're starting with iteration, and it can literally freeze your program solid.
So why does this happen? It's actually pretty simple. Look back at our code. See that last line inside the loop that asks the user to guess again? If you forget that line, the value of the guess variable never ever changes. So if your first guess was wrong, the condition guess not equal to target will be true forever, and that loop will just run on and on into infinity.
All right, let's just take a step back and recap what we've done here. In just 2 pretty simple upgrades, you've added some incredibly powerful and, frankly, fundamental concepts to your programming toolkit. Let's break down exactly what they are and why they matter so much.
This table really sums it all up, doesn't it? First, we used relational operators, like greater than, to make our comparisons. Then we used nested selection to handle those multiple outcomes and give that really specific, intelligent feedback. And finally, we wrapped the whole thing in a while loop to repeat the game until the winning condition was met. See? Each concept solved a very specific problem for us.
And honestly, this is the most important thing to take away from all this. We didn't just fix a game. We learned the fundamental building blocks of almost all interactive software. Conditional logic and loops. This stuff is what allows programs to respond to what a user does, to adapt, and to perform complex tasks. These are the tools you're going to use to build everything, from a simple calculator to a massive video game.
So, that really just leaves us with one final thought. You now have the tools to create programs that don't just run and stop. You can build things that can interact, guide a user, and adapt based on input. The ability to control logic and repetition is a huge step forward. So the only question left is, what are you going to build with it?